So now that we know how to differentiate, it's very important to remember the beginning of this topic, like why we are learning differentiating and what it actually is. If you remember back to first principles, which is the start of the topic, we had this notion that, okay, if I differentiate a certain function, this is how we do it. Right? Now, if you recall where this came from, it's actually everything to do with the gradient, right? So calculus is all about change, okay? Now, the thing with curved graphs like this, which is pretty much the majority of graphs, is at each point, the rate of change is always, they're all different, right? As opposed to like a straight line, it's constant. And so we were interested in finding the gradient at any point on the graph, yeah? And just from our normal gradient understanding, if we have, say, 2 points, then we can use the gradient formula to find the gradient between those 2 points, right? This becomes a little bit more difficult when we're trying to find the gradient when we only know 1 point, okay? So that's why calculus kind of was born, okay? So we have this idea of, okay, let's calculate the gradient between 2 points, okay? And that distance was actually h. And as that distance of h gets extremely small, we're eventually going to get to the point where we can find the gradient of just that tangent. Okay, so it's always important to remember like what differentiation and calculus actually is. You'd be surprised how many times like I've seen so many students that are really good at differentiating, and then I'll ask them the question, well, what is it? Like, what is differentiating? And they actually can't give me an answer. It's always useful to know as well, like if you understand it, then that goes much further than, you know, just memorizing or knowing like a routine process. Okay, so all that to say, in this video, we're going to learn how to find the equation of a tangent. Okay, so we have this very complicated looking formula, right? So equation of a tangent is that. I'm just going to write under it. You might be maybe more familiar with something like this. Say y minus y1 is equal to gradient x minus x1. So hopefully this you've seen before. And this is just basically finding the equation of a straight line, right? So the equation of a tangent is also a straight line. So we're just going to use our straight line formula. Okay. The only thing with this notation, they just wrote it in function notation. Okay, so we're going to try to sort through this. Okay, and we're going to actually try to do a question. Okay, so let's try question 1 here. It says, find the gradient of the curve of this parabola at the point where x equals to 1. Okay, so I'm just going to draw, you don't have to draw a graph, but I'm just going to draw a quick one just to illustrate what's happening. And this is some parabola, right? So like some parabola like this. And the question is asking for the gradient of the curve at the point where x equals to 1. So let's say x equals to 1 somewhere here. And at this point, we want to know, like, if we were to draw a tangent, we want to know what is the gradient of that tangent. Okay, so if we come over here and we try to differentiate, we get 2x minus 2. Okay, and I'm also just going to keep mentioning the names of these particular functions. So for example, this one here, this is called the gradient function. Okay, so once you differentiate it, it's the gradient function. It's a function because it requires an input. Okay, and for us, our input is x equals to 1. So we can say for x equals to 1, m equals to 2 times 1 minus 2. M equals to 0. Okay, and then this is the gradient. Okay, so notice the difference between a gradient function and an actual gradient. Okay, the gradient is a specific value. Okay, so we found the gradient to be 0. Now this is the correct answer, but just coming over here to the graph that I drew earlier, it seems like if it's a gradient of 0, looks like the 1 is actually somewhere around here. Okay, again, this is not really a graphing question, but it's just to illustrate. Hopefully you guys can recognize that a flat line has a gradient of 0. Okay, so it looks like that is the gradient that we found. Okay, let's try just one more over here in question 2, and then we can try to actually get the tangent. So in this question, again, it's just asking for the gradient. So it says the curve of this parabola has a gradient of 1 when x equals to 2. So let's find the value of a. So let's differentiate this first. A is just a constant number, so 2ax minus 7 is our gradient function. And then we can say when x equals to 2, m equals to 1. Okay, m is just the letter I'm going to use for gradient. Okay, so we can say, so 2a times 2 minus 7 equals to a gradient of 1. Okay, so we can sub it into our gradient function. We get 4a minus 7 equals to 1. And just do a bit of nice algebra, and then we can find the value of a. Okay, so hopefully that is easy enough to find the gradient. Let's incorporate this and actually find the equation of a tangent. I actually want to, let's try this question here. So it says, the function is 2x squared minus 8x. Okay, so they gave us the diagram. And it says find the x value where the gradient is 4. So 4 is a pretty steep positive number. So it looks like it's this one. And so we need to find the x value that will give us this coordinate. Okay, so this x value there. Okay, so how do we do this? Well, let's just start with our function. And then we can differentiate this. And it says the gradient is 4, right? And this, we have the gradient function. So let's just come over here to the side, and I'm going to say, when is this gradient function equal to 4? Okay, so what value of x is going to give us a gradient of 4? So you can move 8 over there and divide everything by 4. So we get x equals to 3. Okay, so, whoops. That's like 3. And then lastly, find the equation of the tangent at this point. Okay, so this is just asking, this is the tangent. What is the equation of that tangent? Now remember, a tangent is just a line. Okay, it's just a straight line. So to find a straight line, this is our formula. We need a gradient and we need a point. Okay, so we already have a gradient, m equals to 4. And we need to know this point, which we know the x value of. Okay, so let's just sub it in and find the y coordinate as well. Okay, so our equation was 2x squared minus, what was it, 8x? Yep, minus 8x. If we sub 3 in, so let's say f3 is equal to 2 times 3 squared minus 8 times 3. What's that? 9, 18, minus 24, so it's minus 6. Okay, and that seems about right, like minus 6. Okay, so we have the coordinate 3 minus 6 and a gradient of 4. So if this was x1, y1, we can say y minus negative 6, which is y1. Gradient is 4, and x minus x1. Let's just simplify this guy. So y plus 6 equals to 4x minus 12. And this is our final answer. Okay, so hopefully that was helpful. So that's how we find the equation of a tangent. In the next one, I'll go over how to find the equation of a normal. Sweet, thanks.